Hi everyone, welcome to our Tech Talk. Today's episode we are going to talk about 3D printing. 3D printing is a very exciting subject, especially for me and Amit. Both of our background is mechanical engineering, so 3D printing ties in very well with that. It is also one of the newest manufacturing technology, or the concept of manufacturing an object. This method is relatively new. So I've done some 3D printing before. Amit also have some experience on that. So we thought that this is a very hot topic right now, and it would be really good to talk about this. I think our viewers and listeners would benefit greatly from the knowledge and experience we have gathered from our various projects that we've been involved in. So yeah, 3D printing is a fascinating subject. What do you think about it?
Um, First of all, thanks for the introduction to the interesting topic. 3D printing
Yeah.
actually is quite relevant, and also because it's now so cheap to get a 3D printer and start manufacturing just in your home, that it's now accessible to everyone who wants to start printing something. And
Mm-hmm.
we already print at home. We print papers, we print postcards, we print cards, etc. So we already understand what printing is. 3D printing just adds a additional layer on top. You can now print in three dimensions instead of just two dimensions, which is length and breadth. Now you can print in height as well, and that's where
Yes.
3D printing is so advanced. And the reason it's getting so popular now is because the price has come down. Anyone can buy the printer. The material
Mm-hmm.
cost is very low, and you can create a lot of rapid prototypes. So suppose you want to build a part in your home to fix something, and you don't want to buy it, or it's not available in the market. You can actually print it, customize it,
Mm-hmm.
print it, and then start using it immediately in your house.
Yeah.
And that's the power. So yeah, I'm quite excited to talk about it.
Yes, absolutely. It is very powerful in terms of manufacturing technology. It's very powerful, and as you said, so we could look at it from two different ways. We have printing. We know the concept of printing, and we've always been doing 2D printing, and now adding another third dimension enables us to create 3D objects rather than printing on a piece of paper. And that's one way to look at it. The other way is manufacturing technology. We've been using various methods, historically, to manufacture different objects, different products that we design. But there has been some limitation on the kind of product that we could manufacture. 3D printing is a new method of manufacturing something, and it kind of opens the door to create some products which isn't possible to manufacture using other traditional methods. So yeah, it is very powerful and it is very interesting, and the doors that it opens are and the opportunities that it creates are immense. So yeah, very very excited to talk about it today.
Indeed. So let's jump in right away, and let's try to understand what do you mean by 3D. So when we talk
Mhm.
about dimensions, we talk about length, breadth, and height. And as I mentioned, in a printer, you print on a piece of paper, which is still just a piece of paper, just a different type of paper. Then you print books, and then you print your credit cards. So those are also printable.
Mhm.
So you can print those cards. You can print your scan cards, ID cards. So those are also printable, but they are all
Yeah.
having two dimensions, a length and a width, and you just print on top of it. And 3D printing just adds additional layer. So three dimensions stands for length, breadth, and height. So that's why it's 3D. And printing, because you are trying to print something. So how printing works? Print actually presses something, a image or a copy of something on a piece. So it could be a piece of paper, an ID card, a plastic, postcard, whatever. So you print something by pressing an image or a copy of that image onto that object, and that's printing. In 3D printing, actually, You don't print a 3D object. You create a object layer by layer. Um,
Mm-hmm.
and you are also a mechanical engineer, and you know how we used to work in mechanical engineering workshops where we use a lathe machine and we put
Uh-huh.
say cylindrical rod, and then we use the lathe machine to create a screw out of it, right? But what's
Yes.
happening in that process? You take a material and you subtract, right? So you
Yes.
subtract, that's subtractive manufacturing. And in 3D
Yes.
printing, you add. So it's additive manufacturing. So what's happening is
Yes.
you're adding layer by layer. But yeah, I mean, we'll go into depth a bit more. But I wanted to understand from your experience what you think about this.
Yes, absolutely. So yeah, as you said, there are subtractive manufacturing methods, and then there are additive ones. Absolutely right. The 3D printing is additive ones, and in terms of manufacturing, as you mentioned, we had lathe machines, and then there was milling, grinding, various things. These are all, you start with a block of the material, and then you take things away from it. And then there are other things like CNC machines, where you could also have quite detailed, precise designs added onto it. But again, CNC machine kind of takes away, chips away the from the original block of product. But I think one of the reason this additive manufacturing method didn't come, it took some time to come to this stage, is because of the material. You need
Yes.
to have a material which is moldable, but also becomes fixed, becomes solid very quickly, and in a way that is easily controllable. So when it's soft, you could mold it to shape however you want, and then by the time you are doing the next layer, by that time the first layer, or the previous layer, has to be solidified, so it can hold the layer on top of it. So yeah, material, obviously advancement of material technology has enabled 3D printing to a degree as well. So yeah, I mean, as far as manufacturing technologies goes, this is a completely new way of building things, and I'll give you an example actually. So say for example, if you want to build a sphere, but you want to have another sphere inside a larger sphere. So the only way you could do it is with 3D printing in one piece. So you could create half a sphere, two half spheres, and then join it by welding or whatever. But if you want the bigger sphere to be one piece, the only way you could build this with another sphere or another object inside it is by doing it with 3D printing. There is, all other methods would require you to have two different pieces and then join them together. There will never be one piece. For example, CNC machine, or even milling or grinding, you might start with a cube, and then you chip away to make it a solid sphere. But how would you make it a empty hollow sphere? By chipping away, if it was a
Yes.
solid block. um, with 3D printing, this kind of design is possible. That wasn't possible at all before. 3D printing also enables you to do some complex designs that would have been very difficult to do, or very difficult, not just difficult, but time consuming and costly to do with other traditional production methods. For example, if you want to create a mesh of something, like just for example, if you want to create a cube, but a hollow cube, but all the corners of the cube, how many corners are there? 8 corners. So if you want to connect all of these 8 corners in a mesh to each other, even if you want to use traditional, if you use traditional method, you could potentially build it, but it will be very costly. And It would also be very time consuming, and there might be various other weaknesses as well. But with 3D printer, you could, create it exactly how you want the shape to be, and it will create it with no problems. So yeah, there are many benefits of 3D printing. Actually, I mean, we're kind of diving into it, but yeah, I mean, that's enabling different complex design is one of the unique benefits of 3D printing. And then there is prototype building. One of the things, any product designer would be, really excited about is to build their idea, that is in their head, to build it in flesh and blood, in real life, something that you can hold and touch and see whether it works in real life and how it interacts with the environment, etc. So for that you need a real life prototype. And you know various other manufacturing methods, using them you can create prototypes, but some of them are so costly to create one product. If you're using, like, for example, sand casting, or you have to create a mold first, and then creating that mold is very expensive, and it has to be exactly the correct shape and size of that mold, and then you can create a prototype. And then after creating the prototype, if you realize, oh, you know what, I don't like this, or it needs subtle tweaking of this corner or whatever, then you have to create the mold all over again, and that's again very costly and time consuming. But with 3D printer, you can just create a prototype, you can just print it. If you don't like it, print it another one, with the design amendments. And this is just two of the benefits off the top of my head. Saving cost, speed, all of these things are also there. Yeah.
And it's interesting that you touched about so many concepts like CNC machines and etc. And I think it would be fair to say that we need to explain to our viewers and listeners what CNC machines are. So in traditional methods of manufacturing, a human would use to operate a machine, and they used to set the tool at a particular distance from the object that has to be milled or machined, and then they used to operate that while the machine is moving. With CNC, what happened is it just automation. So automation of the task which the person used to do physically, now you don't need a human being. So it's an automatic control of the tool that mills the material to create an
Mhm.
object. So that's computer numeric control, that's CNC machine. And Rinat mentioned a couple of things: additive manufacturing, creating an object inside an object, which actually is quite difficult. I think it's impossible to do from traditional methods, because you have to, I mean, create an object inside an object, which is like crazy. I mean, people can do it. Like you can have something set up on a wax which melts on its own. But yeah, I mean, it's not possible with the traditional methods of manufacturing. So when it comes to 3D printing, what Rinat mentioned was layering. So you need a good material that fuses or gets solidified very quickly once it's put in. So what happens is the printing machine has a tube-like structure, and it gets the material in the form of filaments or some liquid or something, and then it starts to so it's like a toothpaste coming out of a tube. So slowly
Yes.
the toothpaste is coming out as you press it, and then you move the tube, so it creates a shape, and the shape is coming from a design, and the design is something that we create in computers. And
Mm-hmm.
Rinat had talked about it, that was 3D CAD. So we talked about
Yes.
AutoCAD and Autodesk Inventor, where you can create 3D designs, and those
Mm-hmm.
designs are broken down by software into multiple layers. So so suppose you have a cube, you break it into layer by layer, you break it into say two-dimensional layers. So
Mm-hmm.
you have a
Yes.
3D object and you break it into two-dimensional layers. So what does one layer of a cube look like? It looks like a piece of paper. And then if you
Yes.
stack pieces of paper, it becomes a cube. So similarly, in
Yes.
3D printing, you take the layer and you make the first layer using the tube. So you press it, or it pushes it out, and then it moves in that direction and puts the material on the base layer. Need to have something supporting the object, and once you lay the first layer, then you move up, and then you lay the second layer, then you move up, lay the third layer, and you continue progressing upwards. So it always starts from the bottom to the top, and you finish at the top. And as you progress upward, the layer below solidifies or gets fused, and in the end you have
Yes.
a product. So it's kind of amazing how people thought about this whole idea. I was like, okay, this is so interesting and so fascinating.
Yes, absolutely. That's actually a really good way that you explained what 3D printing is. Actually, yeah, that is what we, that is one of the the basic fundamental questions that you answered. That yeah, what is it and how does it all work? Yeah, layer by layer, each layer is a 2D print in one sense, and then if you stack them up one after another, and if how are their positions, positioned layer by layer, then you end up with a 3D object of it. And yeah, the crucial thing is the fact that it solidifies the layer as it is, as the the filament, the toothpaste like consistency coming out of the tube. As soon as you do the first layer, by the time you're moved on to the second layer, the first layer solidifies in room temperature. So it's like if viewers and listeners, if some of you have used glue gun, you might be familiar with the glue. So the glue itself is a solid tube, and then when it goes through the glue gun, it's heated, so it's then moldable consistency. And then once you put it wherever you want it to apply it, after a few seconds it kind of solidifies and attaches the two things you're trying to attach. But in the case of 3D printing, it's very similar. It just solidifies a little bit quicker in room temperature. So it's heated, the filament, usually plastic is used for it, and then it just solidifies and holds the next layer.
Yeah,
Yeah.
I think yeah that's a good analogy. A lot of people use a glue gun. I've
Yeah.
used in my house, so you get some a glue, and then you put it in a gun, and then you spray it. So I think it exactly. And you're right. The heat part I missed, because you have to heat the element that you want to use to create the object, and then it
Mm-hmm.
slowly cools down at room temperature,
Mm-hmm.
and yeah, then it solidifies. And it's interesting because most of the 3D objects will have kind of that pattern on their surface, and you can see that very clearly because you see that everything has been created using layers. The pattern that's created, or the object that's created, is not that smooth on the outer surface because you see the layering. So I think you might have to do some additional processing, but the advantage is you can create any possible design you can think of. As long as you can break the design into two-dimensional layers, you can create any object. While you were speaking, I just thought we are already actually quite familiar with it in a medical field. MRI, the MRI scans, they're all
Mm-hmm.
two-dimensional scans of a particular part or organ of our body.
Mm-hmm.
So we never see 3D scans of our, say, lungs or heart. We always
Yes.
see the doctors, they see 2D scans, and they use the MRI machine or the CT scan machine to create multiple layers or slices, as they call it in medical terms. The
Yes.
reason I know this is because I've been to hospitals quite a lot, thanks to all the accidents. But yeah, I think this is something which everyone might have observed if they have been to a hospital and if they have accessed MRI or CT scan machine, not accessed but used it, in the sense that they
Yeah.
create
Yeah.
multiple slices of the image and they stack it to create a three-dimensional view of, say, your ligament, your muscle, your tissue, anything.
Exactly, slice is absolutely the perfect word to use, because that's what exactly what it is. If you take a 3D object, and if you just have one slice cut off from the middle, and then look at that slice from the top, that you'll be just looking at the 2D of that exact plane. And if you just now reverse that process and add the slices back together, then you know end up in engineering we call it cross section. I mean, when you
Yes.
are cutting off a 3D product and just want to see how it looks from one plane, yeah, the cross section of product. And then if you have that information and build layer by layer, then you kind of reversing that process and ending up with the 3D object again.
So yes, I mean that the whole idea of doing it is actually quite interesting, because in industries and in other sectors, people are using it to build cars, people are using it to build rockets. Elon Musk said that he wants to build his next rocket using 3D printing. Now, of course, there is a challenge because you're creating a huge object which should not have any material defect, and it has huge amounts of fuel that should not explode. I mean, when it burns, it should not explode inside it, and the material
Yeah.
should be able to withstand the pressure. So, of course, there are challenges to overcome, but because it doesn't involve human intervention, you can now create objects without, you can automate the creation of objects.
Yes.
And this automation is not bound to your homes. This means that you can now create objects like a house. So my
Yes.
wife's cousin, he's actually studying um, construction engineering and how to use these concepts of automation and other things. And they are now thinking, okay, if we want to create a house, every time we need human labor, what if we can print the house? So you cannot print bricks, you cannot print concrete. So that's the challenge that they are trying to solve in university, how to print concrete.
Yes, absolutely. I mean, I think I have read an article. I think, they are working on, or maybe they have already created a prototype of a 3D printer which would use concrete or cement as the filament, or as the material. And they are looking at, I think, they have built a model house based on that. And I mean, it's the methodology, it's the method of creating, doing the 3D printing. That's what's important. And what material you use, obviously, that is modifiable. If you want to create a small plastic toy, you can create, use plastic for it. If you want to build a house, you have to obviously do the research and innovation to find the right material which would be suitable for it. But yeah, I mean, all of these other things are amendable, modifiable, and waiting for us to do the research and innovation to come to it. But yeah, you can absolutely build houses. And also, with the current technological advancement in actual 3D design, relating to the talk we did earlier, now we have a better understanding of how to make a structure stronger using less and less material. So yeah, traditionally we've been building houses with cement, but there could be other materials which are easily 3D printable. It could even be some form of plastic, not the maybe not the moldable plastic, but there are different types of plastic, like ABS plastic and that kind of thing, which are quite firm actually. And with the correct design, which distributes the load properly, etc., you could actually create, quite big, strong structures. And who's to say that house has to be built by wood or cement? I mean, why not a newer material which is lighter, and as long as it can hold, take the weight that is required, and protect you from external, weather incidents like rain and things like that. Then it's perfectly fine way to look into new ways to build houses. But yeah, speaking of different application, actually, another thing I also heard of is, now I think this is very cutting edge. I think I don't think if they've even been successful yet, but they are. Apparently there's been research going on to create human organs, 3D print human organs,
Yes.
which will then, be placed as a substitute for transplant, organ transplantation. So yeah, I mean, using this methodology of manufacturing, the 3D printing, layer by layer, you could do many things. Human organs, you might think, oh wow, how could that be possible? But no, it is, there is research going on at this very moment. So yeah, it is very fascinating.
Indeed, indeed. I mean, you just like showed us the possibilities or the limits of this technology. Like, okay, we can now create an organ, and we don't have to worry about those. So when people take implants, like a heart implant or a lung implant or a kidney
Ah,
implant,
yes.
they have to take medicine so that their own immune system doesn't attack the foreign organ, because the organ doesn't
Yes.
belong to them. So they need to take immunosuppressant medicines throughout their life. It enhances their life, it prolongs it, but then they have to keep taking these medicines. But what if the
Mhm.
foreign object is inert? It doesn't react with anything. So our body will not attack it. I mean, even if it attacks, it won't do any damage, and we can live without taking any medicine, and that would be so
Mhm.
transformational for every human being.
Yes,
So yeah, it's
absolutely.
quite interesting. The other thing I wanted to talk about 3D printing is the softwares. So now there are so many softwares which people want to use, and what we'll do is we'll mention the some of the softwares that people can use actually to slice their 3D designs. So you can take any design which you use in any design tool. Say you design some 3D object in, say, Autodesk Inventor, and you want to then get the slices. The slices are just basically the coordinates at which the machine should inject the material, so it creates the whole object. So what happens is, in the 3D printing software, the 3D design is broken into different slices, and each slices has the coordinate, and what's the difference in the height from the base. And once we get all the coordinates, it's fed to the machine. So like you send a print file, you send a print design, and that design goes to the printer, and the printer then starts manufacturing. And like a printer, you don't have to stand there to wait for the print to come out. You can go have a cup of coffee, come back, and the printer prints the paper. Similarly, in 3D printing, you can go outside, do whatever you want, come back, and maybe after a few hours, your design is ready. So yeah, I mean, these are some of the basics that you need in actually um, if you want to start 3D printing, because you need a printer, you need a software that talks to the printer, you need a 3D
Mhm.
design that's broken into slices by the software, send it to the printer, and then you start printing. The other thing which Rinat mentioned is the material. So now we are at a stage where we have advanced manufacturing materials, where we have these plastics that are much more durable. And Rinat, I think, yeah, you're absolutely right. We don't have to build houses using concrete and cement and bricks. And if we can build a house very quickly, then the advantages are that if we have a cyclone prone area, and if suddenly it's been hit by a cyclone, we can rehabilitate people by taking the printer there, taking the material,
Mhm.
manufacturing the houses there, and ask people to start using it.
Yes. Absolutely. I mean, yeah, obviously there are benefits of, maybe I suppose there are benefits of brick houses, but then there are limitations as well. But then those limitations are not limitations when you're 3D printing it using a different material. For example, the cost and the speed.
Yes.
A 3D printed house can be probably built in 2 days, whereas a brick built house, you have to dry the cement, you have to do various other things to it. All of these things are just taken out of the equation with 3D printing. So yeah, absolutely. I mean, it is really helpful in certain situations, like environmental hazard and that kind of stuff. It could be very useful. And then also, like more underprivileged areas, and then poorer countries where finding a place to live is difficult, etc. Or building a house, uh, like maybe even for you could create a village of homeless people where very quickly a series of house was built and then given to the homeless people, and then a big problem within various cities where there are a number of people are without homes can be solved very quickly.
Yes, and want to mention another thing. I mean, you talked about people creating prototypes. So these are for all the startup founders who want to create a prototype. Me and Rinath, we were just talking about creating something, and we thought of sharing that if you want to build a prototype very quickly of something to show to the investors who want to invest in your company, then you can get a 3D printer, maybe just rent it for a few days, create your prototype if you have the design ready in your software program, and then get the object printed. Once you have the physical prototype in your hand, it's actually easy to convince people that okay, at least you have something in physical form. It's not some idea that's sitting in your computer. And that's again quite helpful when you want to go out and get funding for anything.
Yes, absolutely. I mean, to be honest, I mean, I was actually waiting to talk more. 3D printing and product design, they just goes so much hand in hand. So yeah, absolutely. I would urge all the listeners and viewers that whatever idea you have, this is something that you wanna 3D printing is something you wanna find out more about if you're anything to do with product design. So first, let me start with this. Like, before half a century ago, maybe there are a lot of creative people around us, and you might come up with so many, awesome, cool ideas in your head, and then you have no way of, realizing it, no way to bring this idea into a reality. It could be for many things. It could be because you don't have the funding to create a prototype, you don't have the expertise you need to sort of, maybe you did a product design, but it needs to take a weight, it needs to support a weight, and you don't have the mechanical engineering understanding whether it can take that weight or not, but you didn't have the necessary supporting tools to make that idea into a reality. And one of the main thing is that when you build a prototype, so many ideas become solidified, or you realize that that was a crappy idea to begin with. But in order to do that, you have to do this initial big investment to create a prototype. You have to go to these prototype making companies, and then that if you have to do that every time you have an idea, very quickly you will run out of all of your personal budget, and then maybe your fourth idea would have been an amazing idea, but by the time you reached your third idea, you don't have any more energy to do it anymore. So 3D printing allows you to create prototypes which will not only very quickly let you hold it in your hand, let you see how it works in an actual real life physical space, but also you could also kind of tell whether it will work in terms of the structural support. Say for example, it needs to, even anything that you want to create has some sort of mechanical aspect to it. Even if you're not creating something just to support load or weight, even if it's for a daily use, for something completely different, it's still throughout is during its usage it will still come across weights onto it, and you need to actually make sure that can it support this weight. I might be creating I don't know, designing a lamp which has nothing to do with weight, but you need to still see that if the lamp was placed in a certain place, or the bulb, the size of the bulb that will be fitted onto the lamp doesn't restrict another design you put around the lamp. Things like that. All of these things can be easily tested by creating a 3D printed object, and it will cost next to nothing compared to an actual prototype building. And with that you could modify the design, first time you design the prototype, and then once you see it in real life, you can identify so many other weaknesses or so many other ways to improve, and you can do all of that. So yeah, I mean, anyone who's doing product design, 3D printer is a must. You definitely should know about it, and you should probably invest to own one as well. I mean, another thing to do, it could be that you can actually build a 3D printer by yourself as well. You can actually buy the individual components, and it's actually quite a fun project to build one. I mean, when I have some time, I actually have this project in my mind that I'm gonna buy all the individual items and then build a 3D printer myself. That way I can make it a little bit bigger, the size that is suitable for the things I want to print. So yeah, I mean, a product design, absolutely, 3D printing is a must to know, and just going through the life cycle a little bit as well. Amit, you already mentioned all of these individual components you need. For example, the 3D design software. One of our talks, we dug deeper on this topic. But yeah, AutoCAD, Autodesk Inventor, CATIA, SolidWorks, these are some of the 3D design software which product designers or engineers would use to create the 3D object in the computer. So once you have that 3D object, then you pass it on to, you can export it as whichever file format you like, and then you pass it on to the software which is dedicated for the 3D printing. So that software will take in that 3D object, slice it however the 3D printer understands it, and then feed that information to the 3D printer. And then the next step is that you have the material that's based on the 3D printer you own. You might use plastic, you might use some other sort of composite material, but yeah, you feed in the material and then you just wait and while the 3D printer prints the object. And then you can do so many analysis on it. You could do weight distribution, you could even do crash analysis. Maybe you have built a design for the front of a car, or some sort of crash analysis, and that is a lot of the times that is to do with the shape of the item rather than material, and how one shape is safer than the other. You can easily test that by creating printing these two different shapes and put it through crash test, and then find out very easily. And because both of them are made with the same material, you can take material out of the equation, because you were only then testing the shape of the design you made. That way you could be more objective about the design advances from of the product rather than the material advances. So yeah, these are some of the ways you could apply 3D printing and the life cycle or the process of it.
Yes, I think I'm quite actually interested in the idea of building a 3D printer yourself. So do you have a list of all the parts of and how to source them?
So it's actually available on the internet. I have actually seen like a 1 hour YouTube video where this very enthusiastic guy actually built it from scratch, and he noted and showed every single step he took to create this 3D printer from scratch and the material that he ordered. So in UK there is a company called Radio Shack, or I think they renamed it
No,
now.
I think it's in US.
Yeah. But in there is a similar kind of shop. I think they renamed it. I can't remember the name, but yeah, I mean, you don't have to go to that particular shop. I mean, there are many places where you could buy these raw materials or the nuts and bolts and exactly what you need. The chain and the belt and the motors and all of the individual components can be easily bought actually, and it's going to be a lot cheaper to build your own as well. Just the individual components, if you buy them separately, it's like 10 times cheaper. And then you have the step-by-step guide, and not just and that's just the physical part. And in that video he also actually showed the software part of it as well, that how do you install a software, how would it take the 3D product in the 3D design from the computer, and how would it feed into the printer, etc. So all of these things are actually covered in, and that's not the only YouTube video. There are actually few YouTube videos of building this 3D printer, and there are other websites as well. So yeah, this is actually a very, very fun project. I mean, to be honest, if viewers and listeners, if anyone is kind of a DIY freak like us, definitely worth giving it a go. And also, it could also be a very fun project if you have like a like a young nephew or niece, or your children, like maybe 10 to 12 years old, and you want them to get into engineering or get into understanding how things work, etc. So it could be a very fun project to do it together with them, because it's actually easy enough for even young people to understand how the whole thing is working, and they would help you, and it would also make them interested in doing something. And once you build something, you can also build it suitable to your needs. Like, for example, when you go to buy a 3D printer, it will tell you the maximum size it will be able to print. But maybe you could, and usually it's the cube shape, like they would say, oh, the maximum object you can print is 30 centimeter by 30 centimeter by 30 centimeter. But maybe you could maybe you don't maybe you are restricted in space in terms of height or width, but you have a workspace or a table which is quite long. So you could actually build a 3D printer which can do a very long piece of print a very long piece of thing. So this is ideally suited for your need. For example, if you want to create a Star Wars sword, I don't know
The
what do you call
lightsaber.
it. Lightsaber, yes. Sorry, I can't believe I forgot the name. If you want to print a lightsaber, for example, you need a long, you need the 3D printer to be able to, ha- cover the whole length of the lightsaber you want to build. If you want it to as a one piece, I mean, you could build it as part by part and then assemble it. But what's the fun in that? I mean, 3D printer is all about creating in one piece, and the part which lights up, you could make it with a material which is meshed, so you can put an LED light inside it, so it actually lights up. So for that, you might actually want it to be, or need it to be, one piece, and for that you could build a 3D printer which can do longer pieces rather than having a cube-shaped maximum capacity. You could have like a 30 centimeter width but 1 meter length, and then so yeah, it's a very fun project. I would very much encourage the listeners and viewers to do it, and let us know, send us your pictures, and I when I have some time, I'm gonna try and do it myself as well. So yeah, we can all see who did the best one.
Yeah, I think that would be a very fun project. And I think the main thing to understand for everyone is like in your printer. So you have different sheets of paper and they come in different sizes, A4, A3, A5, etc. And depending upon your printer, you may be able to print on some pages and you may not be able to print on some other pages. So I
Mm-hmm.
think Rinat mentioned it correctly that you need to think about what's the maximum size that you want to print and then decide on buying your printer. Don't just buy any printer and then think, okay, we are now limited because of what we can build. So think about, okay, if I want to build an object of this size, how much space do I have? What is the printer size available that can manufacture this? How much does it cost? And then go buy it because it's very important. Don't buy a printer that prints small objects. So yeah.
Yes,
So
then you're kind of stuck there. So yeah, absolutely. I mean, obviously, if budget could be an issue. So if depending on affordability, obviously that is one thing to consider. But yeah, I mean, if you do end up with not as big a capacity you would like, then you still can print things, but you just have to print smaller parts of it and then attach it. And so you have to do a bit more of legwork in designing how the assembly will attach itself to each other, that kind of thing. But yeah, I mean, definitely consider the maximum capacity before buying.
Yes, yes, I think that's quite important. And while you were talking about the product design and other things, I also thought of, okay, in our day-to-day use, how we can use a 3D printer. Like, I want to make a phone case, I want to build a tripod, I want to build a laptop stand. I don't want to buy a laptop stand. There are many things in our house that we don't want to spend too much money on, like a laptop stand, like a tripod, like a phone stand, things that you can buy very cheap on Amazon. But it would be quite a good use if you can just get the design from somewhere. And I think the best thing about the internet is today, it opens up the possibilities in a way that you could have never imagined. You don't even have to make the design. The designs are already available. Someone has actually
Yes.
created a design, put it on the internet for you to download and just print it. So don't worry about, okay, what design software do I need? How will I be able to open it? How will I create? What will I create? There are designs available on the internet that you can just download and print it.
Absolutely. I mean, yeah. Speaking of that, I mean, I've heard of a few interesting 3D printing 3D printed objects. I mean, literally just if you just Google interesting things to 3D print, you'll see like so many cool and awesome things people have already printed, and they've uploaded the 3D design. As you were saying, Amit, that you don't even have to do the 3D design. You don't even have to know AutoCAD or Autodesk Inventor or anything like that. You can just download an already printed, already designed object and print it yourself. That's one thing, and then there are other things like around the house. There are, you know, in any house, even though if it's the perfectly built house, there are corners which are one of a kind. Especially if you have an attic room, at the very top floor, the ceiling is not a standard one, and then there are other rooms where you have a different kind of corner, or you put your furnitures in a way that sometimes some space is being wasted, maybe a tiny bit of space, but you could build. So that's why the 3D printer could be really useful. You could build a bespoke product, a structure which will help you with exactly your house dimensions, or your that corner that you can't use. I mean, for example, if you have in your kitchen, if you have two cupboards next to each other, but sometimes you have like a little bit of space in between, which no one can ever use, and that's just being unused. And so you could actually 3D print with that exact width of that space, and it will slide into that space, and you could maybe create a spice rack in there or anything. So yeah, I mean, people have done. I've seen many examples where people just created very small, tiny things, like some things, little things that you could hold it in your hand, but it fits perfectly with one corner in the room, which maybe your table is a square table, but the corner of your wall is not. There is a bit of a edge in it, like or a chamfered area in there. So you could have a 3D printed little object which will fit into that space and make the table fit perfectly in the place where you want to put it. I mean, the first thing you could try is just creating a door stopper, like a wedge, which yeah. So yeah, there are many things you could do. And one of the things I've seen is this guy created plastic is the most common material. So out of plastic, they 3D printed like a toy ship, but it has a big hole in the middle, which is the size of an avocado seed. So and then he has an aquarium in his house, and then that toy ship has this hole which is just slightly smaller than an avocado seed, or avocado rock, whatever you want to call the seed. And then what he's going to do is he's going to put that ship on his aquarium so it floats around, and in that hole that he created, he will put an avocado seed on it. Now, I wasn't aware that avocados grow on, just water like that, or maybe they do, maybe they don't. But you know, that seed would be, or it could be a food for the fishes in the aquarium. I don't know. The point is, that's another innovative way of using 3D printer to do something that you just can't buy from anywhere. So yeah, I mean, there are so many cool ways to use 3D printing. Is amazing.
It is, and uh, I think yeah, it's so these are all the custom designs. I mean, there are standard designs, say a chair, a table, a glass, a
Mm-hmm.
bottle. So those are standard designs, but custom design, like based on the size of the room, based on the problem at hand, you can design something and then create an object which you cannot get from anywhere in the market because no one
Mm-hmm.
actually makes those those custom designs, and this is just specific to your need. So that's again the advantage, a custom design that just fits your needs. And while you were talking about this ship, I realized that I actually saw an article where a lady made a face mask because of COVID,
Oh,
and
right. Okay.
she used a 3D printed strap. So the glass you can buy like an acrylic or something, you can buy it,
Mm-hmm.
and then you need to have some holes in it, which you can easily punch it. But then the strap around to make it more comfortable, and the joint in which the strap fits the acrylic, that has to be designed. So she designed the whole small thing, a very tiny thing, and she put the design out on the internet so anyone could print it and then make it. And she told, okay, these are the list of things that you need, and using this 3D printed design, you can actually create your own face mask if you don't want to buy something. And I was like,
Right.
this is
Okay.
so cool. So
Cool.
yeah.
Yeah. I mean, that's the thing. I mean, if even if you are short of innovative ideas, you could literally just go on the internet, see what other people are doing, and we were talking about it the other day. A lot of ideas are actually permutation and combination of existing ideas. So
Yes.
once you look at 10 cool things that other people have done, I'm sure you will also think of another. Your brain will just automatically come up with another cool design after looking all the existing cool design patterns.
Yes. And I think we have covered quite a lot today on 3D printing. So, is there anything else that you want to add, Rinath?
um No, no, wait, this was actually quite a fun talk. But
Yes.
yeah, I mean, I just want to reiterate to the listeners and viewers that, yeah, definitely look into it. It would be a fun project for you to build it yourself. And if you can't be bothered with that, then probably invest in one. Or you might be able to, if you know that you're just going to use it this one time, you could actually send it to some 3D printing shops where they would print it and send it back to you. You send the design. So yeah, definitely try it, see how it how what kind of finishing you get, etc. And yeah, then try printing things. If you come up with really innovative designs, then you could even publish it in various product design communities. And if it is something really innovative, really useful, you have no idea how far you can go with it. I mean, I think one of our previous talks, we talked about we were talking about renewable energy or something, and then I was urging you guys to come up with design to how to harvest. For example, wind turbine is a design. Then there are like ways to generate renewable energy from sea waves, etc. So you might come up with a design which will harvest natural sources of energy, and 3D print it, and then you could prove that it works, and then you can get to the next stage, and then go to Dragon's Den to get your funding. Or yeah, I mean, definitely this is a big milestone for any innovative listeners and viewers out there to get your ideas into a physical reality, and then you know uh, go go forward from there. So yeah.
Yes, Renat, I think you summarized it really well. I think it's for the innovators, the creatives who have a design in their head and want to build something. This is a great tool. And I think one of the reasons we chose this topic to talk about is because a lot of us are now stuck at home because of COVID during lockdown, and we want to maybe work on some projects, but we are not able to do that. We don't have the right tool or right things, and we are now trying to explore topics like 3D printing, and last week we talked about Internet of Things. So these are things that you have easy access to now, and you can do something at home. So 3D printing, it might sound a very big term, but it's actually now quite reachable to consumers. It's not just the industries or the big manufacturers who have access to this technology. Even consumers like us have access to this technology. We just have to invest a little bit of money, and then we can create very interesting designs. And during this lockdown, who knows, you might actually come up with a design that might end up winning so much funding that it becomes huge, and you end up selling a lot of it. So yeah, I would urge everyone who's listening to this talk or who's watching this video, if not um, buy it outright, but explore and think about, okay, what are the possibilities, and can I actually leverage from this technology? So yeah.
Very well said, Amit. Yeah, absolutely agree with that. So yeah,
Yeah.
that's about it. Thank you very much, guys, for listening. And as always, definitely remember to subscribe and like if you enjoyed the video. And um, again, if you'd like us to cover any particular topic, or if you have any questions that you'd like us to answer, or maybe you're an expert in a particular topic, do reach out to us. Our contact details are, in the YouTube video as well as in the podcast link. So yeah, definitely reach out to us. Any feedback is greatly appreciated. Hopefully, we'll see you guys again next week, and we'll talk about another interesting topic.
Yes,
Thank you very
absolutely.
much, guys.
Thank you so much. Bye.
Thank you. Bye.